Okay, part two. I meant to erase this first, but I hit record too quick, so I got it. Guess what? You can ask questions on Monday. You'll run into some of these. Just put a note like you did, say, hey, let's look at 13 or 14 or whichever problem it is. Okay. All right, so next thing today, so what we're going to look at is two things. We're going to look at symmetry, which then is going to lead us to know what's an even function and what's an odd function. Oops. And we're going to look at what are called piecewise functions. And, okay, so let's look at symmetry. All right. So there's three types of symmetry that you're going to see. I'll show a graph that has each one. This has a symmetry. This graph has a symmetry. And this graph has a symmetry. All three have what we would consider symmetry around a major axis or a major, indicator on the coordinate plane. So the first graph on the top left, you would say is symmetric about what? Y-axis, okay. And obviously we know what function I'm using. This is y equals to x squared, okay? So that is symmetric about the y. Well, there's a test to show it algebraically. I mean, we can look at a picture and be like, yeah, that looks symmetric. But you can't, it's not really a proof. So there's something that has to happen numerically. So let's look at this real quick. Right here, if this is the point 1, 1, what's the mirror point on the other side? Negative 1, 1. What happens to the x? Yep. What happens to the y? Stays the same. Okay. If this is the point 2, 4, what's the mirror point over here? What happens to the x? What happened to the y? So if this is the point x, y, then this should also be the point negative x, y. And that's our test. So this is how you test to see if a function is even. If you plug in negative x, it should not change the equation. It should be the same equation you had. So if you sub in negative x and you get the same equation, then you have y-axis symmetry. Okay? All right. So if I look at the equation y equals x squared, if I plug in a negative x, that means I plug a negative x in place of x, which is going to be negative x squared. Okay. Well, what happens if you square negative x? It becomes positive. Y equals to x squared, and thus it's symmetric about the y-axis. You've shown it there. So as long as what you start with and what you get at the end are the same, then you have y-axis symmetry. All right, so you're going to try one without even looking at the picture. I'm going to give you a graph, y equals x to the 4th minus 4x squared. I want you to see if it has y-axis symmetry. So wherever you see an x, you're going to put what? Yeah, so sub in negative x for x and simplify. I think you know what's going to happen, but just go ahead and show the work. And this is how you're showing that it does have that symmetry. Then I'll show you the graph of this one in a second. You can go in and do homework and only do part of it, right? And it just stores it, right? I think I'm going to say piecewise for Monday. Just take it easy because you got a quiz, so I don't want to overload you. Okay, so what happened? Wherever you see an X, you put a negative X, right? A negative X to the fourth power, anytime you raise a negative to an even power, it comes out what? Positive, so you get X to the fourth minus 4 times X squared. You have the same problem that you started with, or same equation that you started with, therefore it has y-axis symmetry. Anybody know what this graph looks like for plus 500, minus 500 points? Like that, it's a W. A W. It's not just a wider parabola, it has other hills and valleys. Okay? All right, there's that. So we'll save that rule. All right, that's how we do that. So now let's go to, let me erase this one for now. Let's go to this one. So the graph I've drawn, is this a function, first of all? No, it's not a function, but it still has symmetry, so we're going to test for the symmetry. This looks like it's symmetric about what? The x-axis. Well, now notice now the mirror point is here. So what's changing this time? Is it, if I go to this point here, which is say 4, this is the point 4, 2, guess what point this is here? 4, negative 2. So in this case, it's that what stays the same, what changes? X stays the same, y changes. So instead of going and doing a lot of this, if this is the point x, y, this should be the point x, negative y. Well, does anybody know this equation, what it is? Yeah, you can write it like that. It's either, you can either write it x equals y squared or y equals plus or minus square root of x. It's actually easier if I leave it like this because I'm going to show you what the test is. So the test is this. Since it was the negative, since it was the x that changed, we used negative x. Guess what we're going to do here? We're going to sub in what, do you think? Yeah, we're going to sub in negative y for y and see if the equation stays the same. So the test for x-axis symmetry, sub in negative y for y and see if the equation is equivalent. All right, so I get x equals negative y quantity squared. X is y squared, yes. All right, but in terms of, if I'm testing for, notice what are the next two bullet points, even function and odd function. If you look at this graph, can this be an even function or an odd function? Not even knowing what if you don't even know what an even function and odd function are. Can this be an even function or an odd function? Why not? It's not a function, that's exactly right. Fails the vertical line test, so it's not a function. We'll talk about what an even function, odd function. They have these symmetries. All right, and then the last picture I showed you was this one. It was supposed to be y equals x cubed. It's this graph. So if I look at a point here, if it was the point 1, 1, which this graph has, you know what the mirror point is. And you're going to say, well, mirror, it's kind of like a twisted mirror. It's like this. This is symmetric about the origin. It has origin symmetry. And what that means is two flips. If you flip it about the y, then flip it about the x, it should land perfectly there. So origin means two flips. And so, sorry, what point was this? Somebody said it. Negative 1, negative 1. If this is the point 2, comma, what's the point? 8, yes. This is the point what? All right. So now what happens to x and y both? If this is the point x, y, this has to be the point what? So guess what I got to sub in? I got to sub in both. So on this one, since they both change, if I sub in both, I should still get the same answer. So to test if it's symmetric about the origin, sub in negative x for x and negative y for y, and you should get an equivalent equation. So if I have y equals x cubed, sub in a negative y for y and a negative x for x and see what happens. Simplify it as much as you can and see if you still get the same equation. And that's how you show that it's equivalent. Well, what happens? What happens when you cube a negative? You get a negative. Now, if you have a negative on the left and a negative on the right, what can you do? Cancel. Okay? Now, let's just say we had y equals x cubed minus 5x plus 1. If you think it's odd, what are you going to plug in? If you think it's if you think it's symmetric about the origin, what are you going to plug in? Negative x and negative y. But you remember, you got to get the same equation. If you think it's y-axis symmetry, you would only plug in a negative x. So let's just look real quick. Well, if I plug in just a negative x, well, it's not going to come out the same here, so it can't be symmetric about the y. So I'm going to see if it's symmetric about the origin, so I'll plug in a negative x and a negative y and see what happens. So go ahead and work this problem out and see what you get. See if it meets that criteria for being symmetric about the origin. Yeah, what do you think? Yes or no? Correct. Good. So we're testing right now for what symmetry? The origin, since I put both negatives. So what happens here? This comes out to be negative x cubed, right? Negative 5 times negative x becomes plus 5x plus 1. Well, essentially, all you're going to do with this negative is go over here and negate everything, and it should flip it back to this. But it doesn't, does it? So when you go and take and you cancel, so if I multiply both sides by a negative, that cancels that. If I multiply this side by a negative, I get x cubed minus 5x, but I get minus 1. Well, what does that mean? Yeah, it's not symmetric about the origin. So it just doesn't have the symmetry, okay? All right, so no symmetry in terms of about the origin, okay? So a graph that's symmetric about the y-axis, we call this an even function, okay? And a graph that's symmetric about the origin, we call an odd function. Is it rocket science why we call an even function an even function, an odd function an odd function? Is there a giveaway? Right, it's not always with the exponent though, because like for instance, cosine of x, which is a trig graph, is an even function, but it's got no exponent. So it doesn't have to have an exponent to be an even or an odd function. But it's kind of makes sense there, right? Now, another way to say this test is that, hey, I'm plugging in a negative x and I should get the same answer, is we can say that f of negative x should equal to f of x. Because basically what we're saying here, when you plug in a negative, your y should stay the same. All right? So that's the test for an even function. And for an odd function, what has to happen? Well, when you plug in a negative x, you need to get the what of the original. You won't get the same answer, you should get the what? The opposite, negative f of x. That's really your test for an odd function, is what we're doing. Negative x, negative y. Okay. Well, you're okay with plugging these in to check? Like which one is which? Okay. And the only one you plug negative y on is if you're looking for what symmetry? If you plug in a negative y only. X-axis, but that's not an even or odd function. Okay. That will get you everything in 1-3. We've already done difference quotient. It gets you everything but piecewise, and I want to wait and spend time on Monday with piecewise. This piecewise has a little meat to it, and I want to make sure I take some time on that. Okay? Good. Any questions about that? Have you done even and odd before? Yeah. Easy. Hopefully. Everybody good? All right, I'm going to stop there. Good job today.